Now, this idea of relational databases, or the relational model, is really just a way to describe how we're going to store the data in the database and how those individual pieces of data are going to contain relationships to each other. So the relational model has been around for a really long time. It's based on math. It's actually based upon something called tuple relational calculus. And so now you know that, tuple relational calculus. That's as much as I'm going to teach you about tuple relational calculus in this course. So please don't stop listening to the course. We're not going to get deep into the math here. But it is important to remember that there is a rationale. There is a reason, a logical reason for the way that relational databases are set up. So in a relational database, we store data inside of something called a table. And a table is probably the closest construct to, let's say, a spreadsheet that we have in a database, right? A database has tables. Each table has a name. And each column in that table also has a name. Now, each column is going to have restrictions. Restrictions in terms of the size of the data, the type of the data, the format of the data. Columns can also be required or not required. So in this particular example I'm showing you, the email address column is clearly not required because we have some null data there. So every row will contain at least all of the data for all of the columns that are required. Now, we want to get this data out at some point. So the way we're going to get this data out is by asking questions of the database. So a typical question might be something like, what are all the contacts in my database that have a last name that starts with the letter F? And what we're going to do is we're going to take those questions and turn them into SQL that we're going to be able to execute against the database. When we do that, this is known as querying, right? So querying the database is asking questions of the database and hoping that the database will give us back an answer. Now, the database doesn't always give us back an answer. Sometimes that's because the data just doesn't exist. Sometimes that's because maybe the database wasn't set up in a way that allows us to ask that question. So let's think about this example of contacts and the example that I showed you where I've got a first name column, a last name column, an email address column. And what if I want to ask the question, what are all the email addresses that John has? Well, obviously, I can only get back one, right? So what if I have a contact that has multiple email addresses? What do I do then? Well, essentially, I'm stuck. There's nothing for me to do, which means that this particular database design is bad. It's not the kind of database design that you would want. Now, sort of instinctively, you might say, well, let's just add another column. Let's just add an email 1 and an email 2 column. Well, that doesn't really help either, because what if somebody has 3 email addresses or 4 email addresses? Right? We don't want those kinds of limitations in our database design, because that's going to limit the kinds of questions that we're going to be able to ask later, right? In fact, if you see a database design where column names have a number in it, please sit down and question that database design, right? That is, generally speaking, a red flag that something is wrong with that database design. Not always, but most of the time. So the way of dealing with this problem is to do what we call database normalization. So database normalization is a process that allows us to design a database in such a way that we can ask better questions later on. So in my simple example, what we would do is we would normalize that data by taking the email data out of the contact table and creating a separate table that we could call email. It doesn't matter what the names of the database tables are. What matters is the design. And so this really illustrates this idea of relational, because what we have is we have a relation between the person table or the contact table and the email table. And we're using keys, which are our way of matching up the data between these two tables to create a relationship. So now the contact table has a relationship to the email table, and the email table has a relationship back to the person table. And this is going to allow us to ask better questions like, what are all of John's email addresses? How many email addresses does each of my contacts have? Now, there is a much deeper art and or science, depending on your point of view, for normalization, which again is not part of this course. The main idea that you want to keep in mind is, let's make sure that the database design that we're making allows me to ask the questions that I want to ask today and will work well enough to be able to answer the questions that I want to know tomorrow or in a week or in a month or a year. Now, that's not always possible. Again, as I said, database design or normalization is sort of more of an art than a science. But you want to keep these kinds of things in mind, right? And if you just keep in mind, what are the questions that I want to ask? You're going to probably do pretty well. So the point is, database design will control what questions you can ask later. SQL is going to be the language that we're going to use to ask those questions.